Okay, everybody, this is Josh Glenn. I'm doing a quick tutorial for some folks that were asking me about how to set resolution for a machine. And what I'm going to go over right now is what I call the absolute method for figuring that. And that is basically where we're using the science of things rather than checking against the actual distance that the machine moves. So first of all, what I've done is I've opened the Windows calculator here. And I'm going to go to the View menu and put it on Scientific mode. And we see that we have a few added functions here. We have the only functions that we'll probably be using are the memory clear, recall, and memory add, and then the pi function and 1 over function. You'll learn more about that in a little bit. So what I'm going to do first is I'm just going to open up a document here in this program called Corel Painter. It's just a little drawing program. It's allowing me to draw on a tablet just like I would if I was drawing in a notebook. I'm just going to draw a little diagram here. What we have in the case of this example is our motor, our motor shaft, and our motor pulley. That's also called our drive pulley for the purpose of calculating a gear ratio. Then we have a larger pulley over here. That larger pulley for this example is a 72 tooth. This smaller pulley is a 15 tooth. And of course there's a belt that stretches around both of them. Okay, and what we're using is a 1.2 inch pitch diameter spur gear. Okay, so that's our gear system. So I'm going to open up another page here. And this is where I'm going to start the actual calculation. So let's say that we have a Gecko 210 step motor driver with a 10 microsecond step division. That means that we'll have 2,000 steps per motor rev. That's at a 1.5 degree step angle. Okay, so if we take 2,000 and multiply that times our gear reduction, then that will give us the number of steps it takes to move the output shaft 1 revolution. So first of all, let's calculate our gear ratio. We have a 72 tooth driven pulley, and we have a 15 tooth drive pulley. So if we do the math on that, we got 72 divided by 15 equals, 72 divided by 15 equals 4.8. So that's 4.8 to 1 gear ratio. So what we do now is we multiply 2,000, that's the number of steps in a motor's revolution, times 4.8 equals 9,600 steps per output gear revolution. Okay, so 9,600 steps per output gear revolution. Now let's open up another page here. 1 revolution of the output shaft equals the pitch diameter times pi. Okay? So the pitch diameter of our gear is 1.2. So we multiply on the calculator here. 1.2 times pi equals, and we see our result right there. 1.2 times pi equals 3.7699. Okay, so we have our circumference. Now we multiply 9,600 steps per revolution of the output shaft times 3.7699. That's the distance the machine travels for every revolution of the output shaft. And what do we get? We get excuse me, did I say multiply? I meant divide. 9,600 divided by 3.7699 equals 2546.4866. 2546.4866 steps per inch.